Okay, let's go on to the next one. I skipped over one of the slides, resources. I'm doing slide number 8. You can take a look at number 7 if you're going through this video, and you can walk through it and make sure you understand it. So Alicia jogs each morning before school. An app on her phone records her pace over the course of her 40-minute jog. So she's going for 40 minutes total. Use the key features of her jog to determine which graph could model it. So this is just kind of a real world function. So we know it's 40 minutes. So this goes 40, this goes 40, this goes 40, and this goes 40. We're going to check that first. So Alicia's starting pace is 0 miles per hour. So it's got to start here at the origin. So that eliminates C. So C cannot be correct. Okay. Alicia's fastest pace is 6 miles per hour, occurs from the 20th to the 35th minute. So it's 6 miles per hour, which is right here, right here. We already know it can't be C. And so it stays all the way across here, so that eliminates D. So now C and D are eliminated. Alicia's pace is increasing from 0 to 20. So from 0 to 20, it increases. From 0 to 20, it increases. So both of them still could be it. Her pace decreases from 35 to 40. Both of those do that. And then she starts jogging at 0 minutes and stops at 40 minutes. So right now, based on this, and I see the difference now, which at first I didn't notice, because notice that these graphs are the same except these have arrows. And remember, those arrows means it continues. Now, can we have a negative time? No. Can it go over 40 minutes? No. So it has to be B. Okay, so B would be the answer. So what assumption was made to graph the situation? Alicia's pace increases and decreases at a constant rate. That's one thing. Alicia's speed is constant. No, it said that, so I think it's A, because that's the only one it didn't really talk about that it was increasing or decreasing at a constant rate. And what that means is notice that we had a straight line instead of, she ran a little bit faster at first, and then she went slower, and then she went faster, and then she went slower. So it isn't jagged in that case. Okay, next one. Here is our check. You want to be able to do the check of sketching graphs of functions and get that done and turned in. So that should help you get to that point. But we're going to continue forward since we stopped in the middle of these resources. Okay, now we're comparing properties of linear functions. We're just checking to see which ones has something different. So what I just want you to do is see them a little different in this case. So notice here we have a function with table, and we have a graph, which doesn't seem to be showing up. This is just what it's explaining. So the graph has a slope of -4 and passes through these points. Since it has a slope, it has to be a line. And then we have 2 points, so that's okay. Okay, so which statements about both of them are true? So as x increases, f of x decreases. So as x gets larger to the right, f of x goes down. So that's decreasing, correct. Slope of -4 means that the line is going down. So they are both decreasing. The y-intercept of f of x is greater than the y-intercept of g of x. Well, the y-intercept is when x is 0, so it's -3. So 0, -3. This one, they're the same. So it's not greater. G of x decreases faster than f of x. Notice that for every 2 seconds, right, it's decreasing. So that would be, so that you would actually figure out the slope here. So the slope would be the change in y, which would be -1.5, over the change in x, which would be -2. So that would be -1.5 divided by -2. So -1.5 divided by -2. So we have -1.5 divided by 2. What I'm going to do is I'm going to multiply both of those by 2 because it's easier for me to see. So that's -3 over 4, because that doesn't change it if I multiply top and bottom. So that means that I have a slope of -0.75. So which one is going down faster? The -1.75 or the -4? So if we look at those, the -4 is going down faster. So g of x decreases faster. That's correct. Both functions have the same y-intercept. That's correct. We determined that when we were looking at the y-intercepts here. The x-intercept of f of x is greater than the x-intercept, so when y is 0, so negative 4. So which number is bigger, negative 3/4 or negative 4? G of x would have a larger one. So g of x is greater than the x-intercept of y of x, so that's not true. F of x decreases faster. Oh, look at that. G of x decreases faster, f of x decreases. Okay, so notice these are opposites, and if this is true, obviously this can't be true. So I think we're good. Keep your fingers crossed. Yep, got them. Okay, so we got them all. And that's what's happening when we're comparing those different functions. So you got to go through them one at a time. Notice I had to use a sheet to go back and figure out at least one of the numbers. Okay, comparing properties again. This one's just giving us some information so we can see the difference between the two. So the x-intercepts of f of x, so here's an x-intercept, here's an x-intercept, of f of x are greater than the x-intercepts of g of x. So the x-intercepts are 2 and 0, so that would be 2 and 0. So it looks like g of x is greater than, so it has to be the f of x has to be less than. Y-intercept of f of x, which is this one, which is 0, 1, 2, 3, 0, negative 6. So it is greater than the y-intercept. The relative maximum of f of x, which is located at negative 1, positive 4, is, and that's really not a relative maximum, that's actually the maximum, is relative maximum of g of x. So the relative maximum is located at 4, 2. So that means the y value is 2. This y value is 4. So that means that the relative maximum has to be greater than. And I think that should be okay. Okay, looks good. So we just go through those. We go to the next resource. And I think we have another check. And we are now done with section 1.1.